Okay, we can go ahead and get started. This week is a continuation from the previous week, which this month of May is all about performance enhancement. And so this week, or last week, we were talking about speed development. This week is discussing training power, specifically within the rehab context. And so we'll get into kind of some variables that you can pay attention to when you're going through a rehab progression to make sure that you're covering everything that you need to. Give the overview. This is my 2 cents. The rehab should be a lot like a gradient. It should be smooth from start to finish. It shouldn't be any big peaks or valleys. It shouldn't be any massive jumps. Nothing introduced should be drastically different from what has already been previously established. Strength tends to get measured in rehab, but power tends to get forgotten. I think that a lot of clinicians will look at things like max force production without looking at the context of how fast that force is being produced. Force velocity curve is king. This is definitely true if you're looking at things like power, if you're measuring how fast things are moving, whether that's bar speed or whether that's how fast the body is moving. If you're doing things that are body weight, plyometrics would be relevant here. And then definitely when you get into the more sport specific stuff. And then lastly, the isolation versus compound movement selection, making sure that you're understanding the nuance there of training isolation, but then also transferring that to the compound movements. So, talked about this a little bit earlier. The rehab should be a lot like a gradient. It shouldn't just be okay. Your pain is gone, so get back out there and get back into your sport. And this is pretty well understood by this point. I think most clinicians do a pretty good job of grading their return to play. It's not just a okay, once you're pain free, you can get back out there. You typically have to go through a progression where you're restoring range of motion, strength, power, and then going through some kind of an on-field or on-court return to sport progression. I think that there's a couple of illustrations or illusions that are helpful in terms of kind of conceptualizing this topic. So the first is the square and the shadow illusion. If you've ever seen this before, the A and the B squares look drastically different. Obviously, the A square looks a lot darker than the B square. But if you take a pencil and cover up the line, it actually is the same exact color. It's just the context of what's around it that makes it look different. So I really like this idea of creating a gradient in the rehab. And so if you think about it in terms of, this is actually a pretty common practice in art classes, is you're creating a value scale where you're creating the darkest possible color, where you're using something like charcoal, and then you're doing the lightest possible shading technique. But ideally, if you cover up the middle line in between any of these two colors, you shouldn't be able to see the difference in those two colors. It should only be apparent because there's a hard line that kind of tricks your brain into seeing the difference in colors, but they should be as smooth as possible is the goal there. And that's what I kind of think about when I'm doing my rehab is, how close is a calf raise to doing something like dunking a basketball, for example? Like, that's still a pretty far way off. So just because they can do a calf raise doesn't mean that they're going to be able to dunk a basketball successfully without pain. So if you're progressing that rehab, there's probably some intermediate steps that you can take to make sure that that process is smooth. And that's kind of the topic of power in my mind. So, like I said, strength tends to get measured, and there's all kinds of different devices that are measuring strength, whether that's manual muscle testing with just without any equipment and no objectivity, progressing that up to handheld dynamometers. And of course, there's all kinds of different brands and companies that are making different devices. But you get into some of these more advanced products like the Nord board or the Force Frame. There's the gold standard for ACL clearances, which is the isokinetic testing. And then lastly would be the force plates. And this depends. Force plates you'll see fall into both categories because it depends on what you're looking at when you're using the force plates. You can use them for say like a mid-thigh pull isometric test, and you're just getting a force production or a force output test. But you can also look at force time continuums to determine how the force is being applied. So we'll get into. There's a really good book on that if you're interested, called Takeoff by Daniel Bove. We'll talk about that a little bit later in the supplementary literature. But as you can see, the list for strength exercises or strength testing is a lot more vast than it is for power tests. There's a few different companies that make velocity-based training devices, but there's not that many clinicians who use them, to my knowledge. It's more common in a gym space or a performance training space than it is in the rehab space. I think that this is something that probably should be utilized more often. And I don't think the objectivity is crystal clear yet. I don't think that it's precise enough to maybe rely on, but I think it's more objective in terms of the velocity or the power output than just using your eye to gauge how fast something is moving. Watt bike is a common, it's a cyclical application, so it's kind of tricky to apply in terms of things like jump tests, but at least watt bikes will tell you your wattage. So that's your true power measure of what you're producing via your lower body. And then lastly, like I said, force plates can be used for power tests depending on the information that you're seeking out. So the force velocity curve here, the curve speaks for itself in that there's different applications of force and velocity. Obviously, that's in the name, but there's basically different dimensions of, okay, how fast is this weight moving? So you've got the really slow dimension. So on the far left, where the force is really high, this would be something like a really heavy deadlift or a really heavy back squat, where you've got really heavy weight, but the bar is moving really, really slow. And then you've got kind of, typically when you see this curve, people will map out like 2 or 3 different dimensions where you've got true strength, you've got speed strength, or maybe power, depending on the terminology that they're using. You've got, and then you've got true speed all the way at the end. So if you're doing the, in a rehab, you're going to progress people typically from lower speeds first, but you're also going to progress the weight as tolerated. So couple different dimensions that you can play around with if you're trying to progress somebody on this force velocity curve is maybe they can't do maximal effort heavy weight yet, but maybe they can move that bar pretty fast. So you can still get really high force produced because you're moving at relatively high speed. And so then you also have to take into consideration with that is you're going to have athletes that are on a spectrum from strong to fast. And so some athletes are crazy strong. They can back squat 2, 3, 4 times their body weight, maybe even more. And then sometimes those athletes are fast, sometimes they're not. But then you've got also athletes that they can't even squat the 1 times their body weight, and then they're crazy fast. They're like Olympic gold medal fast. So you kind of have to take all of this with a grain of salt, or at least taking the context into consideration of who is the athlete that you're working with. What is the adaptation that I'm trying to create? Am I trying to make them stronger? Am I trying to make them faster? And which dimension or which axis am I going to target in this force velocity curve? So definitely pay attention to when you're in that power phase, the later stages of the rehab. Pay attention to, do I want more force output or do I want more velocity output? And just cueing those things when you're doing an exercise can be a big difference in the adaptations that you're going to get. Lastly, the isolation versus the compound movement. So somebody could have a really good calf raise isometric strength, and that could be grounds for clearance into like an on-field return to play or return to sport. A lot of times people will say, let's say they've got an ankle sprain. A lot of times people will say, well, if they can do a calf raise with good force production, then they should be good for on-field. Well, probably not, because they're going to have a lot more. One, they're going to have a lot more body parts involved, and that would be the compound discussion here. But then also the forces they experience out there is probably going to be higher than what they're going to be able to output with just an isolation calf raise. So paying attention to how are the calves working in something like a counter movement jump. And again, that book by Daniel Bove talks about the different peaks in the force time continuum, where you're seeing, okay, there's the first peak, and then there's a second late peak, which you get with from the contribution of the calf or the ankle complex in that jump, that force output. So if you see a really small second peak, then probably you're not having as much contribution from the calf in the jump. Whereas if you see a relatively large second peak, then you're going to have probably a lot more calf or ankle contribution to that jump. So being aware of the isolation or the compound movements and the differences between the two. Same thing goes for knee extension. Maybe they're doing some kind of a knee extension isometric test and they're plenty strong, but then you put them on a drop jump and all of a sudden you see some asymmetries. Maybe you see force drop, or maybe you see rate of force development is decreased. So there's different variables that you can play around with force plates if you have, especially with the devices that are split side to side. And then lastly would be the hip abduction. And these are all just examples. There's not any gold or rationale as to why I picked these three different body parts, but just three examples. You can take into consideration whatever body part is relevant for your rehab. But hip abduction, you could do some kind of a hip abduction isolation test and test the hip abductor's strength or force output. And then you could also see something where you're involving things like the knee, the lower back, or the torso in the rotation component, where you're doing something like a lateral bound, where it's a max effort test. And it requires a lot more, I guess, neuromuscular awareness or coordination between those different body parts. For this week's literature review, there's all kinds of good information out there, both in terms of reading and in terms of the media. So for the first reading piece, the strength training versus power training, there's a good article out by Physiopedia that kind of teases apart the differences between the two and the nuances of when you would want to train one versus the other, how you would train one versus the other, and then how you can measure them. Second, there's an article out by Barbell Medicine. This was my first time ever reading their stuff, but it was a pretty good article called How to Train for Power After Injury. Pretty informal, but at the same time has some good information there. And then lastly, Takeoff by Daniel Bove. Sadly, I don't get paid commission for selling that book, but that's a really good book if anybody's trying to learn more about force plates. It's pretty dense. There's a lot of information in terms of biomechanics and force, and like truly like breaking down all of the different variables and components. But if anybody's looking to experiment more with force plates, highly recommend checking out that book to learn more kind of along your way. For the media aspect, the movement system, I always preach his videos. He's got tons of good stuff on the internet, both in terms of written content and in terms of videos. And so he had a video called Rate of Force Development Explained. And then Mike Reinold had a similar video, Rate of Force Development in Rehab. So this is more about injury side of things, whereas the movement system is more on the performance side of things. And then lastly, Dr. Brian Mann has a video explaining velocity-based training, breaking down those different types of or styles of power training. So you've got your really slow bar speed with high weight, or you've got a lower weight with really high speeds. So then that brings us into the literature review for this week. So the publication review this week was an expert opinion, which was submitted to an editorial on NSCA's website. And it was a critical analysis of kind of what is missing in the current athletic training and physical therapy space in terms of rehabilitation. And so two of the things that he was emphasizing here was that the restoration of strength and power is needed in rehab. I don't think that's a surprise to anybody, but that was kind of just laying the foundation for the article. And then lastly was the triple extension being a critical component for any athletic movement, basically. So running, jumping, change of direction. He was emphasizing the need for triple extension in a rehab context. He did say that some people will do triple extension type movements in their rehab, or maybe whether that's intentional or unintentional. But he was pointing out that it could probably be started sooner if you're modifying those exercises, or if you understand those exercises, so that it can be started earlier in the rehab process. He was basically, so again, this is just an editorial opinion. This isn't backed by any kind of data or evidence in this study, but what he was discussing was that without adequate strength, the power can't be achieved. So you have to lay the foundation of the strength before you can get to power. And that applies as well, at least in my opinion, with range of motion. If you are the world's strongest man in an isometric, but then you can't bend your knee through more than 30 degrees of an active range of motion, you're never going to have any kind of athletic capacity because you have to have more range of motion to transfer that force. So if you're really strong but you lack range of motion, you're probably not that athletic. So range of motion, that's why I tend to progress things the way that I do, where you start with complete range of motion before you start to incorporate strength. And then you have to have adequate strength before you can introduce power. He was arguing that the power-based exercises in the terminal phase of rehab are critical. And so that, similar to what I was saying, is a lot of ATs will go through and they'll test strength and they'll say, okay, they're good to go on field now or good to go on the court now. Whereas he's making the argument that there should be more end stage rehab done in a gym context where they're doing power specific training, where you're doing really either fast movements or heavy movements with the bar, and training or selecting exercises that are going to kind of transfer from the isolation style of rehab into the more complex or compound movement of athletic movements, doing things like jumps or Olympic movements, were a couple examples that he was providing for that. He made the argument that insufficient power can lead to difficulty with change of direction. That is definitely true, especially in the context of ankle or knee injuries. He was arguing for Achilles tendon as well, but those are less common than some of these knee injuries or ankle injuries. But it can also lead to overuse injury or re-injury of the body part. And specifically, he was breaking down the details of ACLs in this argument, where he was saying if they have insufficient power or rate of force development, when they get taken into an athletic context, they aren't reacting to the forces that they should be in enough time or in insufficient time so that they can protect themselves. So he was making the argument that with insufficient power, injuries are more likely to occur. Triple extension is a good indicator of functionality. And so again, he was making the argument that the components usually get addressed here individually. So you're doing things like a calf raise and you're saying, okay, they've got good ankle plantar flexion, or they've got a good calf raise, whether that's strength or form. But they're probably missing the bigger picture of doing things like hop testing, jump testing, Olympic gym testing, anything where you're getting more compound in nature than isolation type exercises. So one of the arguments he was making is that triple extension is critical because it's such a good predictor of athletic function. So people should be paying more attention to getting the hip, ankle, and knee all in symmetry with good coordination. Again, so the lack of coordination or the triple extension, and he was saying that that can lead to improper sport mechanics, which could then cause increased pain of the current injury or a new injury. The biggest takeaway I had from this was that the triple extension can be progressed and regressed, and he gave several examples as to how you can do that. One of my favorites was the elevated squat. And so we had an asymmetrical squat with a step up on one side. Basically, anytime you have any kind of a knee or an ankle surgery, you're going to have athletes that are subconsciously shifting away from that involved side, and they're trying to absorb the force with the uninvolved side unconsciously. So if they're doing that, no matter how many times you try to cue them, they're not going to be able to do it. They can watch themselves in the mirror and see that they're still shifting, and they can't always correct it. So one of the things that he was suggesting that you can do is you create the asymmetry the opposite direction, and it forces them to use the involved side to kind of counteract that subconscious or unconscious compensation. But then he goes into the different progressions and regressions of the triple extension. So he has originally starting out on flat ground with a heel raise, getting into a triple extension lunge where they're getting a big press off. You're starting to go against gravity with the triple extension step up. And then he moves into the last piece, which is the power step up, which is essentially the same as the triple extension step up, but you're doing it pressing harder into the box, and then you're stepping up faster to create more force via that force velocity curve. So in summary, rehab should always be a gradient. The more smooth you can make it, the better, and try to progress from range of motion, strength, power, and then get into your sport specific return to play. The strength tends to get measured, but the power tends to get forgotten or overlooked. And power can easily be measured or manipulated in the rehab, especially in the gym where you're controlling bar speeds. And there are a few devices out there that you can use to truly measure those bar speeds if you want to be precise, as opposed to just estimating. The force velocity curve is a big component of the gym work in terms of training for power. So knowing those bar speeds is helpful, and knowing the different variables that play into that, whether it's the bar speed itself or the percentage of their 1 rep max in order to elicit that bar speed. Knowing how to manipulate those variables in a rehab context is something that's important and can definitely improve your outcomes if you're aiming to train the power in rehab. And then lastly, consider the isolation exercises versus the compound movement. So even if they can do something like a pogo hop, can they do a depth drop or a drop jump? Things where they're going to get more body parts involved, getting the knees, getting the hips coordinated with that movement so that they can relearn neuromuscular sequencing and how to really move through those full body range of motion. That will do it for this week. Next week, we'll be discussing core stability and how that can be trained in a rehab context to influence other body parts, such as the knees or the hips. All right. Hope to see you all there.